So, what is a tall building? There's actually no global definition of tall building. In CTBUH statement, it said the building that exhibits some elements of tallness. In the local design code in China, there is a definition of 100 meters tall. So it's always a relative thing. What is tall? What is short? Today we will use 200 meters tall and 50 story as the definition of tall building. Why are we different from the Chinese design code or local code? Is because we found that cost-wise, nowadays with the advancement in construction technology, the cost difference between buildings below 200 meters doesn't differ too much. So when costs come into play, whether the cost per meter square will increase in proportion to its height, or when the height becomes taller, is above 200 meters. But generally speaking, developers tend to build taller buildings, as the tallness of building can bring about certain commercial advantages. You can only buy a relatively small piece of land, and then you can have a large amount of floor space available. Most exciting in the CBD area. This is to say that the floor area, the total construction floor area that I've shown is 477,000 meters square instead of 460,000 as presented by Thomas. Is because the definition of covered floor area that we have to use to calculate the construction cost is different from the gross floor area used. So this area is always is very tricky. It's like the plot ratio area that we use. It's become the company's iconic image. So whenever you look at the building, you remember who's the client. And also, a tall tower attracts the top tiers tenants or buyers because they're usually in prominent locations, they have panoramic views, they have prestigious stages, they offer a high quality working environment. This helps us, as David said, we have 20,000 workers or users later on for the building. And this is to attract all those top tiers, top talent people working in this environment, to attract them to work here and to be retained in the office, in the company. So what is the cost planning and cost control of the tall building? Is that why is it so important? Is because it is a sizable investment, usually it's of a very big scale, and also it's complex in nature, and there is no economy of scale. Why should I say there's no economy of scale? It's because the cost per meter square will increase as the number of stories increase. So it's not, the more you have, the cheaper it is. It's the other way around. And we were involved, or we are involved in the whole process of cost control, starting from the very beginning. I think it's very important in those early stage where as in the main grand ballroom there, the first question that Andy would ask is the economic bubble or small bubble that will affect the whole business plan. So in the very beginning, we'll have to have a reliable budget. So, and at this very beginning, we don't even have a sketch. Okay, so it's when the clients decide whether they're going to buy this piece of land, how much they're going to pay, they only have at that moment to be just the design parameters or the usage of the building. So, and then we will continue to track, number two, item number two, we'll continue to track on the design development changes, because there are more drawings from the architects, from the engineers, from different design consultants. We will verify and compare against the original construction budget. So, this is kind of an interactive process together with the designers. 这是一个跟设计单位之间的一个互动的一个东西。 And then, of course, if there are over budget or things that we can do better value, achieve better value for the clients, then we can do a lot of value engineering exercise. And then we will come to how do we materialize the budget into a actual contract sum, tendered by the contractor. This become not just a budget, but this becomes a contract sum to be committed by the clients by signing the contract with the contractors, and the budget will becomes the contract sum gradually. So it's not a one-off process. Okay, we've been tendering throughout the last 5 or 6 years, and to achieve the maximum overlapping between the construction and the design process, we have to tender to obtain the contractors in different stages. And then once you sign the contract sum, you say, oh, okay, that's good. We signed the contract sum of how many billions? That's it. After 4 years, 5 years construction period, we just paid that sum gradually until the end. We pay them all, and that's the end. In fact, it doesn't happen. There are always design changes during this 4 or 5 years construction period. That's to say, we have to control that design changes process all along the next 4 or 5 years as well until we sign the final contract sum. There won't be one final contract sum as well, as we have different contract packages. We will have decided with the foundation contractors, the excavation contractors, etc. And in the Kenneth Kwan Finance Center, we have been providing the full service from the very beginning to the end of the project. And luckily, at this moment, we've been very successful in upholding the budget. So it's more or less maintained at the moment. At the very beginning, that there's nothing. We have to come up with a number that's realistic and good for not the past 5 years, but good for the next 5 years as well. And architectural planning, there are some interesting features of tall buildings. Deep basement, for us, we have 5-level deep basement. And then, as I said, the floor areas always create some confusion at the very beginning. So we have to be very careful at the very beginning when there's no drawings, no design, only the land use permit, where you have the gross floor area, you have the plot ratio, maybe the gross floor area, because the definition of area is different even in different cities in mainland China. So if you look at this, if you just apply the floor area at the very beginning where you don't have anyone, maybe you just want to think about the budget, you have a feel of what the order it is, you may just take the floor area on the table and then go to the website, check out the cost per meter square, times it by the floor area, and you will miss this very important area, like the refuge floors. Okay, it is countable in some cities, like the M&E floors is countable in some areas. Deep basement, below ground, car park may not be countable, may be countable. So it's dangerous if you don't know the definition of the area that you're using. That's one point I want to highlight, is because, like in Hainan, you will have 5-level basements, 8 refuge floors, 8 M&E floors, and 2 sky lobbies. So this will have significant impact to the budget if you, in the first place, you miss out all these areas. And foundation, I think you have to look at some pictures and know about it. 8-meter diameter hand-up caisson for the magnet column in our case. It's lucky that we are using end-bearing piles for this project, and the rock strata is relatively not very deep. This is to say, for the end-bearing pile, actually, the cost per meter square, if you divide the total cost by the total floor area above it, is cheaper if it is an end-bearing pile, because pile length won't increase by a lot if you put more floors above it. Deep basement, we do have some challenges, as Thomas mentioned it earlier on, when we are having the deep basement of 5 level. is because of the underground workers is more serious than the site investigation report that we have done. The proximity to the underground railway it also creates some problem. The relative small site area and reduced efficiency also cause some increasing costs. We don't have any, we have studied, but we don't use the top-down method. We use the bottom-up traditional one, perhaps due to site restraint. It's all a balance of time and cost. Sometimes the solution that we have chosen is not the cheapest. Okay. For the structural system, it's a combined composite steel reinforcement and reinforced in situ reinforced concrete core. What I want to say here is that, as I said, time is one of the considerations that the client has to consider, and the possibility of obstruction to the visibility from the building is also another factor that the employer has to consider when he determines which structural system to use. Another one that's very important is the efficiency. So with today's technology, we can use actually in situ concrete for many tall buildings, even the 800-meter tall Khalifa Tower in Dubai use reinforced concrete instead of structural steel frame. But the shape, the size shape of the vertical element, how much space they occupy in the lowest floor, sometimes will determine, that it's not just the cost. The cost could be more expensive by using structural steel frame, but it's all this that we have to take into consideration. So it's an informed choice of the employer at the very end. Now this is one of the exercises that we've done to choose the structural system for the building. Previously there is a Verendi system scheme, which is more vertical. You can see there are more vertical elements which will block the view, and also is more expensive than the one at the right. So the one at the right is the one that we have chosen. Here, I think you have seen most of this as well. Just one thing I wish to highlight, that the total steel tonnage, including reinforcement bar and structural steel frame, is more than 300 kilograms per meter square. To put it into perspective, the normal buildings, as I said, below 200 meters, office building, we use about 100 to 100 something kilometers square, kg per meter square. And we have to procure the tar crane at that moment, because it's very early on, a few years ago. We have to procure that in advance for the building. For the facade, you can see, it's uniquely designed. So different building has different images. The facade itself, of course, is very complicated. We may miss out two very important elements as well in the facade. One is facade lighting, cost-wise, right? One is facade lighting, one is the window cleaning system. They are, for the tall building, very cost significant. So another interesting feature that we have is the spire, as David said. But at that time, we have studied different heights of spire. I'm not quite sure why we haven't given height of spire. Perhaps I think the client is not so sure in the next few years whether we're still the tallest building in mainland China. So it have a plan A, plan B, and plan C. It's more flexible. And high quality interior fitting out, high cost. This lift. This is very important, and very cost sensitive as well. So you can see one of them, in addition to cost, is the lift core that the lift shaft will occupy. It's the area that takes into consideration as well. So we have to have high-speed lift. I think it's not the price of a Audi A6, it will be the price of a Bugatti Veyron for a double-decker 10 meters per second. So we have these lifts. They're cost sensitive. I think they are above 100%, more than 100% to 150% more expensive in terms of cost per meter square than the normal below 200 meter tall building. During services, I think I'll skip this because time is running out. We've done different exercise to choose the appropriate M&E systems. And for tendering, we have used the traditional main contractor build-only contract arrangement, which has taken into consideration a lot of limitation in mainland China. And we have also taken a very aggressive tendering and procurement strategy in the early procurement of the basement excavation ELS contractors, foundation contractors separately, structural steel suppliers, steel fabricators, etc., and including the consultants, etc., with more than 100 contract packages. So in conclusion, with the advancement in construction technology and scarcity of land resources, our view is that where there is a financial justifiable business case, it is envisaged that the developers would like the building to go higher and higher. But there are hurdles like the government regulations, environmental issues, so to summarize is that the financial viability of a tall building is the utmost important to the client when they determine to take on such a big project. And it will be to have a realistic budget, to keep on cost-checking the changes, and then through a tendering and contractual arrangement to make it a realistic construction cost for the client.